Mathematics paper 1 is very simple, so is mathematics paper 2. I know some of you right now are stressing because time seemingly has gone, and indeed it has. Okay, to a point whereby some of you, maybe when you try to study, you look at the amount of data you need to cover, you end up becoming stressed and fail to study. I felt like that before. So the key to passing math is in being smart and strategic. You simply need to pick your questions and you start perfecting those questions. Okay, now is not the time for you to be trying to learn everything. You don't have the time to learn everything. So be realistic. Choose your questions, start perfecting those questions, start going through those questions. Like now, once we do area of a sector in calculus, start navigating through different past papers and attempting these questions. Okay, make sure you're able to solve several of those. Once you're able to solve several of those, it simply means you are now good for area of a sector and calculus. Even those that we've already covered, you do the same. Okay, that's how you get to pass math. You just need to be smart about it. Be strategic in your studies. Don't try to cover everything because clearly you do not have time. Okay, this is a curriculum that needs to take about 3 years for you to be able to grasp everything. Okay, and now you just have a few weeks remaining, so trying to cover everything would be unreasonable. That is why I have highlighted the major topics, and that's what we're going to be covering. Okay, so passing math paper 1 requires you knowing several formulas, because math paper 1 is all about formulas. Okay, I cannot emphasize this enough. Math paper 1 is simple, but you need to know formulas. If you don't know formulas, it won't be easy for you to solve the questions. For example, you found a question on area of a sector, but you don't remember the formula for finding the area of a sector. How are you going to solve the question? You can't, even if you know how to solve it. You know to say, I need radius, I need theta, but you don't know how to come up with the formula. That simply means you can't be able to solve that question. So make time as you are studying to also go through the formulas. Okay, revise the formulas and make sure you are good at that. So for area of a sector, the formula we are going to be using is this one. Just one formula. Okay, so this is the formula, which is area is equal to theta over 360 pi r squared. Now this formula is very similar to the one for distance under earth geometry, which is theta over 360 2 pi r. Okay, there are some general differences. Here we have a 2, there we don't have a 2. Okay, and then here the r is lowercase, here it's uppercase. So I've seen students where they make a mistake and they also add a 2 here. That becomes wrong. Okay, so please take note of the difference. Here the 2 is appearing as a power, here it's appearing as a coefficient. So I don't know if that helps, but don't make those mistakes. Okay, sometimes people fail simply because of making very simple mistakes. Okay, so in any formula, you will only be asked to find one of the unknown values. You can see in this particular question, the unknown values we have area, theta and radius, because pi is always given as 22 over 7 in the question. Okay, so they can only ask you to find one of these unknown values. If they ask you to find the area, it simply means they'll give you the theta, they also give you the radius. Okay, if they ask you to find the theta, it simply means they'll give you the area and the radius. Okay, if they ask you to find the radius, they'll give you the area, the theta, and then now you'll be able to find the radius. Like I mentioned, pi is always given as 22 over 7. So that is that about any formula. Okay, go to arithmetic progression. Okay, they can only ask you to find one thing, either the term, the common difference, or the first term. So in paper 1, any formula just requires you to find one thing. That's how come you notice we'll keep using the same formula for all the different types of questions. Okay, so let's now look at some exam questions. So area of a sector, like I mentioned, is a very simple topic. but it can get tricky when you don't know what you are doing, because remember in paper 1 you do not have a calculator, therefore you are not supposed to multiply values anyhow. Okay, only multiply when you know what you are doing. Okay, Madam Chimia says she can't see anything. Kindly try to leave the class and then come back. That should be a network issue. Try to leave and then come back. Use the same link and you should be able to see what we're doing. Is there anybody else who's unable to see the screen? If you're unable to see the screen, simply do the same as well. Leave and then come back. That should solve your issue. Okay, let's just wait for a few seconds for her to get back. As she's coming back, okay, she's back. Are you now able to see the screen, madam? Hi, madam. Are you able to see the screen now?
Yes.
Okay, great. Yeah, so as I was saying, area of a sector is a simple topic, but it can get tricky when you start multiplying values anyhow. Remember in paper 1 you do not have a calculator, so if you just start multiplying values anyhow, hoping that you land on the answer, you'll be surprised. The question will get locked to a point whereby you fail to simplify it. So always, just like I mentioned the time we're looking at variation, always reduce as much as you can, and then only multiply when you have no other option of reducing. So the goal is to reduce as much as you can and only multiply when you have reduced all the numbers. So the first question is coming from 2022 paper 1 GCE, paper 1 internal actually, and the question, as used to say, in the diagram AOB is a sector of a circle, center O, angle AOB is 72 degrees. So the angle at the center here is one that is called theta. Here where you have the 72 degrees, that angle, that's one that's called theta in your formula. Okay, and the radius. Okay, so when it comes to parts of a circle, let's say we have that badly drawn circle there, and this is our center O. The distance from the center to the circumference, the outer part of the circle, is called the circumference. The distance from the center to the circumference is called the radius. Okay, and then the distance from the circumference through the center to the other part of the circumference, you can see it's passing through the center, touching both parts of the circumference, is called the diameter. But in this session we are just more concerned about the radius. So now a sector is basically a piece of a circle. Take it like you have a pizza, and then that single piece, a circular pizza, that single piece, that is your sector. So that is why it is this angle called theta over 360, simply because the entire circle adds up to 360. Okay, so this angle right there is what is called the theta, and remember we said the distance from the center of the circle to the circumference is called the radius, represented by the delta r. So meaning even this one is the radius. So that is that. So you know to say my radius here is what? 14 centimeters. So that is the information that we have there, and the radius is 14 centimeters. Calculate the area of a sector. Remember I said the area of the sector formula is theta over 360 pi r squared. So what are they asking us to find here? They're asking us to find the area. Okay, you can see here they're saying calculate the area of the sector. So since they're asking us to find the area, they have given us the theta as 72 degrees. They've also given us r as 14. So all we have to do now is simply plug in the values we know and then solve for the unknown value, which is the area of the sector. Okay, so first things first, write the formula. Formulas also carry marks. So always write the formula if you are dealing with a question that requires you to use a formula. Then here we can plug in our data table. I like using the data table because it's easier to pick values. So area is what they're asking us to find. We don't know. Theta is given to us as 72, the angle there 72, and then our radius is given as 14, and pi is always given as 22 over 7. You can see here they're saying pi is equal to 22 over 7. So all you have to do now is plug in the values we know into our formula and then solve. So area we don't know yet. We say area is equal to, what is our theta here? We check here, what is your theta? 72 degrees. You put 72 there over 360, and then times, what is your pi? Your pi is 22 over 7. You can see right there. Okay, and what is your radius? Your radius, remember, it's r squared. So instead of saying 14 squared, I'm going to say 14 times 14. Once you do that, don't start reducing from that very step. Proceed to the next step. Just copy everything as is appearing. This is meant to show the examiner to say I plugged in the values correctly. Remember, our goal is to reduce as much as we can. So you can say 7 there, it's a 1. I like starting with the last value since these are the same for easier data collection. And then 7 into 14 there will give you a 2. Okay, that 2, you can say 2 there, 1. 2 into 360 gives you 180. Area will be equal to, so do it step by step. Don't try to do everything at once. You might end up missing some values because you have cancelled a lot of values. So here we just have 72 times 22 times 14 remaining on top, and then down here we have 180 remaining. Okay, you can still reduce this one by dividing with a 2. So 2 into 22 is an 11. 2 into 180 is 90. 2 into 18 is 9. Simply add the 0 there. Okay, then again we can say 2 into 90 goes there 45 times. 2 there, that's 45, and then 2 there, that is a 7. So what do we have left? We have area is equal to 72 over 45 times 11 times 7. Okay, remember on top we had 72, 11 and 7 remaining. So again you check, can I still reduce these values? 11 can go into 45, 7 can go into 45. Okay, let's try 45 divided by 72. What value can go into both of these? Okay, we can try using a 3. Okay, so we're going to say 3 into 7, that is what? 2. Remainder a 1. Right? 3 into 7 is 2, remainder 1. 3 into 12, that's 4. And then 3 into 4, that's 1, remainder a 1. 3 into 15, that's 5. So meaning area will be equal to 24 over 15 times 11 times 7 there. Okay, how do we conclude? 3 can also go into 15 and it can also go into 24. So you can say 3 into 15, that is a 5. 3 into 24 goes there 8 times. So we're going to have 8 times 11 times 7, everything over a 5. So area will be equal to, now we can't reduce any further than this. Okay, so let us see what is going to be our final answer. So we can say, okay, now multiply and then divide by 5. Okay, so I'm going to say 8 times 11, that is 88. Okay, times 7 over 5. So area will be equal to 88 times 7. What does it give us? 88 times 7. Eish, the screen is frozen. Those are network issues now. Today is wild. Today people have serious network problems. Yeah, although I'm currently recording the session, so at least maybe we can refer to the session afterwards. Okay, so 7 times 8, 7 times 7 is 49. Remember that trick I showed you? 7 times 7 is equal to 49. Again, I write 7 times. Okay, what do I need to add to 7 to get to 8? I simply need to add a 1. Okay, so that will give me a 7 there. Then I add 9 plus 7 is 6, 5, 6. Oh, sorry, 9 plus 7 is that is 16, remainder 1, and then 4 plus that 1 is 56. So I not say 7 times 8 is 56. So meaning here I have 56 and here I have 56, since we're multiplying with the same number. 7 times 8 is 56, 7 times 8 is again 56, and then they are going to have a 6, 11, 6. Okay, so on top we're going to have 6, 1, 6, everything over 5. Then we can reduce. Let me just go over what I've done. 7 times 8 is 56, 7 times 8 is wait a minute, what am I doing? 7 times 8, that is 56. You write, I think I missed it somewhere. 7 times 8 is 56, you write 6, remainder 5. 7 times 8, that is 56 again. 56 plus 5, that gives me 61. Okay, still give me the same thing. Alright, so that's what we have, and then we can now try to divide by 5. So I'm going to say 5, 6, 1, 6. 5 into 6, that is 1, remainder 1. 5 into 11, that is a 2, remainder 1. 5 into 16, that is going to give us 3, remainder a 1. 5 into 1, it can't, put a point there, you add a 0 there. 5 into 10, that is a 2. So meaning your area is going to be 123.2. What unit are they using in the question? You check. Okay, so in the question they're using 14 centimeters. Okay, so make sure you mute your mics. Okay, what unit are they using? They're using centimeters. So since it's area is always in squared units, so meaning we're going to say 123.2 centimeter squared, and that will be your final answer, and you are done. Remember, the principle is reduce as much as you can and then finally multiply. Okay, I hope that is clear. If you have any questions, this is how we're going to be doing it for those who are joining us for the first time. If you have a question, you can raise your hand. There's an icon with a hand symbol somewhere on your screen. Just press it, it will show me that you are raising your hand. Then I'll give you an audience, you unmute your mic and then ask your question. Alternatively, you can type your question in the chat. Okay, there's a chat option again within your screen. So that's how we're going to be doing it. The idea is to not have so much interference so that we can only get one person speaking at a time. Okay, we are done with question 1. We go to question 2. So question 2 is saying, in the diagram, AOB is a sector. AOB is a sector. In the diagram, AOB is a sector of a circle, center O. Angle AOB, that's your theta, right? Wait, isn't it the same question? Oh, okay, we're supposed to be here. The diagram shows a sector POQ. Arc PQ subtends at an angle of 45 degrees at the center. Okay, so our theta here is 45 degrees. Remember we said theta is this angle right there. Okay, we don't have radius. What are they saying? Given that the area, so they've given us the area here as 77. Calculate the radius. So first thing first, you write your formula. Area is equal to theta over 360 pi r squared. When plug in your data table here, area has been given as 77, theta has been given as 45, pi is always given as 22 over 7, and then radius is what we're finding. So I'm going to say area, where there's area I'll put 77 is equal to theta is 45 over 360, pi is 22 over 7, and then times radius squared. So remember I said the first step you leave it for the examiner to see how you plugged in the values. You simply copy everything to the next step and then you start reducing. We can say 2 there is 11, 2 there is 180. Okay, can 5 go into 180? Yes, it can. 5 into 18 is 3, remainder 3, that makes it a 30. so you can reduce this by 5. So 5 into 45 is a 9. 5 into 18, that's 3, remainder a 3, making that one a 30. 5 into 30 is 6. So I mean we're going to say 77 is equal to 9 over 36 times 11 over 7 times r squared. We can reduce the 36 with a 9, because 9 into 36 goes there 4 times. Or if you don't know that 9 goes into 36 4 times, you can start with a 3. 3 into 9, that's a 3. 3 into 3, that's 1. Into 6, that's 2. That makes it 12. 3 into 12 will give you a 4. Okay, otherwise, I note the 9 goes there once, and then it goes there 4 times. So meaning I'll have 7 is equal to 1 over 4. Because the 9 got cancelled there, times 11 over 7 times radius squared. Once you've done that, you now notice to say I cannot reduce any values at this point. So what am I going to do? I'm going to cross multiply. Okay, but instead of cross multiplying, I'll simply move the values around. So I'll say over 1, and then I cross multiply, meaning it's going to be 7 times 4 and 7. They're the ones that are down here, so you have to multiply with both of them. 4 times 7 is equal to, this side you're just going to remain with 1 times 11 times r squared. Okay, which you can simplify to be 7 times 4 times 7 is equal to 1 times 11 is 11. 11 times r is 11 r squared. And then you divide both sides by 11. Divide both sides by 11. Now 11 is a special number when it comes to area of a sector. Always look out for an 11. 11 can go into any double digit number. Okay, 11 can go into 11. You can see there's 1 there. Can go into 2, which is 22, 33, like that, 44, and I've seen there's a double digit number here, which is 77. So I can reduce that one by 11. So I'm not going to say 11 there is 1, 11 to 77, that is a 7. So I'll remain with 7 times 4 times a 7, which is equal to r squared. So I can say 7 times 7 is 49, then 49 times 2. So 49 times 4 actually. Okay, 4 times 9 is 36. Remember we did this somewhere up there. 4 times 9 is 36, remainder 3. 4 times 4, that is 16, plus 3, that is 19. So we're going to have 196 on the left, then we have r squared there. So now, how do we get rid of that squared on r? We need to square root both sides. So we're going to say square root there and square root there, so that this guy and that guy can cancel. On the right we just have r. So now what is the square root of 196? Okay, you're simply looking for a number which when you multiply it by itself twice, it gives you 196. Okay, you can start trying. Let's try 12. 12 should give us 144. 12 times 12, this will be 2 times 2, that's a 4. 2 times 1, that's 2. So I'm deliberately doing this. I know the number I'm looking for, but I want to show you how to try. Okay, so 2 times 2 is 4, 2 times 1 is 2. 1 times 2 is 2, 1 times 1 is 1. So this will give me 4, 4 there, and a 1. We go to the next number. How about 13? What does 13 give me? Okay, so I'm going to say 1 3 times 1 3. Okay, 3 times 3 there will give us a 9. 3 times 1 there will give us a 3. 1 times 3 is 3. 1 times 1 is 1. Okay, so this would be 9. That would be 6. That would be 1. Okay, I'm wondering if we've done first the correct thing. Let's try 14. What is 14 times 14? Okay, 4 times 4 there will give us 16. Remainder 1. 4 times 4, that is 4 plus 1 there will give us a 5. Okay, then 1 times 4 there will give us a 4. 1 times 1 is a 1. When you add those, you're going to have 6. You're going to have 9 and 1. So the number you're looking for is what? 14. Therefore, the square root of 196 is equal to 14. Since this is radius, you check what unit are they using. They're using centimeters. Not really. They're using centimeters, yes. So meaning your final answer should contain centimeters as well, since this is radius. So that is your final answer. This, by the way, is the same as radius is equal to 14 centimeters, and you are done. Okay, are there any questions? I keep seeing people leaving and coming back. I guess it's a network problem. It's really sad. Do you have any questions? Okay, seems there is no question. We proceed to the next one. I'll try to interact with the people having network problems when we get to have our break. Okay, next one, same format again. The diagram below shows a sector A or B with center at O and radius is 21 centimeters. The angle subtended at the center is theta, and the area of the sector is 462. So remember, I said the first thing you need to do is write down the formula. Area is equal to theta over 360 pi r squared, and then you plug in the data table there. So what is your area, what is your theta, what is your radius, what is your pi? So area, has it been given? The area of the sector is 462. So area is 462. The angle at the center, which is theta, has not been given. Radius has been given as 21. Pi is always given as 22 over 7. So plug in those values, you know. So while there's area, I'm going to put 462 actually, is equal to, what is your theta? The theta is unknown, over 360 times 22 over 7. The radius is 21, so instead of saying 21 squared, I'll say 21 times 21. So remember, I said leave that part for the examiner to see how you plugged in those values. Don't start cancelling from that very step. So simply copy everything again like that, 21 there times 21. So I can start cancelling. 7 there is 1, 7 to 21, that's 3. Okay, then I can say 2 there, that's 11. 2 into 360, that's 180. I can now transfer to the next step. 62 is equal to theta over 180 times 11 over, okay, there's no need for us to put a 1 there, times 21 times 3. Okay, so 3 can go into 18. We can say 3 there, 1, 3 into 18 goes there 6 times. So that becomes a 60 there. 2 can go into 21, 3 can go into 21, it can also go into 60. So you can say 3 into 21, that is 7. 3 into 60, that should be 3 into 6, that is 2. Add a 0 there. So meaning we're going to have 4, 6, 2 is equal to theta over 20 times 11 times 7. At this point, you will notice that you cannot simplify any further than this. Remember, the goal is always to simplify as much as you can. Once you're done simplifying, that's when you can go ahead and multiply those values. So at this point, we need to move these values around so that we can try to simplify again. So I'll cross multiply. Instead of multiplying, I'll just list the values like that, because it's 462 times 20. I'll list it like that, meaning on the right I'm going to have theta times 11 times 7. I'm also not going to multiply to get 77. I'll divide again both sides by these values so that I can move them to the left. I group the like terms so that here the 11 and the 11 can cancel, the 7 and the 7 can cancel. On the right I'll just remain with theta. Okay, then here I can see, can I reduce? Remember I said 11 is a special number. It will help you reduce numbers that are a bit complex. So this 462, remember I said 11 can go into double digit numbers, right? So let's try. Can 11 go into 462? So I'm going to say 462 11. We know it can go into double digit numbers, so it can go into 44. So 11 into 44 will give us a 4, remember a 2 there. 11 into 22, that's a 2. So I know to say the 11 goes into 462 twice, 42 times. so I can simply cancel that one. 11 there is 1. 11 into 462 gives us 42. Okay, so we're going to have 42 times 20 over 7. Now you actually see to say 7 goes into 42 6 times, right? So I'm going to say 7 there, 1. 7 into 42 is 6. So I'm now going to say 6 times 20 is equal to theta. Okay, 6 times 0 will give us a 0. 6 times 2 will give us 12. So your theta is going to be 120 degrees. Remember, theta is an angle, so you need to put the sign for degrees, and you're done. So this question becomes simple when you know at least the 10 times table. I remember telling those of you from the main class to say you need to know these values. Okay, like for example 2 times 3, 2 times 4, up to 2 times 9. Go to 3 again. 3 times 2, 3 times 3, you go up to 3 times 9. Okay, you go to 4 just like that. 4 times 2, again up to 4 times 9. See how it was easy for me to figure out to say 7 goes into 42 6 times. It's because I know this stuff. So if you want it to be this question to be simplified and any others in paper 1, practice this from 2 up to 9. Okay, for a start you can start with double digit numbers. 2 times 2, 3 times 3, 4 times 4. These are a must. 5 times 5. Know them up to 9 times 9. And then you can start adding the others. That's how you're going to see these values are going to be simplified. So that is that. Do you have any questions? Today we have a lot of network challenges. Yeah, but I'm recording the session, so you can still go through the session afterwards. Yeah, it's still recording. Otherwise, too bad for those having network challenges. Currently in Lusaka we have network challenges because some parts of Lusaka have no power. As a result, certain of our towers here are down. That's how come people are having network challenges. Yeah, but we are actually, you haven't missed much. The principles are the same for this question. Always reduce. Okay, multiply per last. Don't start by multiplying values. Values become too big to a point whereby the question gets locked up. Yeah, so otherwise that is that. We are done with that one on top. If there are no questions, we'll proceed to the next one, which is starting with a bonus question, which is on indicial equations. So this question is saying solve the equation. Let me just go down. Solve the equation 3 to the power 1 minus 2x plus a 4 is equal to 5. So remember we said whenever you are dealing with a question on indicial equations, the time we're looking at indices, your goal is to make the bases the same on both sides of the equal sign. So we're going to say 3 to the power 1 minus 2x is equal to 5 minus 4. We'll group the like terms, the positive 4 will cross to the other side. Then now you notice to say this is 3 to the power 1 minus 2x is equal to 1. This is where it gets interesting. Okay, the goal is to make the bases the same, but this side we have a 1. What do we do next? Remember we said any value raised to the power of 0 is what? Is 1. Therefore 3 to the power 0 is the same as what? 1. So all you have to do now, this one was an interesting question. The examiner tried to be very creative with this one. You're just going to say 3 to the power of 0. Alright, as simple as that. Since the bases are now the same, you can now equate the power. So I'm going to say 1 minus 2x is equal to a 0, and then you group the like terms. Negative 2x is equal to negative 1, because 0 plus negative 1, this one is positive. When it crosses, it becomes a negative. 0 minus 1 is negative 1. Then you can divide both sides by negative 2 by negative 2. Those signs will cancel, those will cancel, meaning x will be equal to 1 over 2, because those signs will cancel. By cancelling, I mean negative divided by negative is going to give you a positive. So your answer there is just 1 over 2. And you are done. Okay, so watch out for such a question. So to answer this one, you also needed to know the law for negative indices. And you are done. We now go to the actual question for this one. The diagram shows a sector AOB whose area is 231 centimeters squared and radius 14 centimeters. So obviously they'll ask us to find the theta since they've given us the area and the radius. The angle subtended at the center is theta. Okay, find the value of theta. First things first, write down a formula. Area is equal to theta over 360 pi r squared. So area has been given as 231. So where there is A, I'll put 231, which is equal to theta is unknown over 360. Pi has been given as 22 over 7. So I'll say 22. What am I doing? 22 over 7 times radius has been given as what? 14 centimeters. So instead of saying 14 squared, I'll say 14 times 14. I said leave that stage for the examiner to see how you plugged in those values. Don't just start cancelling values anyhow. Leave them so that they have reference where you are coming from. Then here you can reduce as much as you can, but be careful, don't have a lot of reduced values. You may miss out some of the values. So then you can say 7 there 1, 7 to 14, that's a 2, 2 there 1, 2 into 180 into 360, that's 180. My mind always races to the answers. You can even say 2 there 11, 2 into 180, that's 90. So 231 will be equal to, on top we have theta over a 90 down here times 11, down here the 7 got cancelled, so I have nothing, times 14 times nothing. Actually the 2 got cancelled as well, we just have a 1 remaining. We can still say 2 there is 7, 2 into 90 is 45. So the more you do this, the more you actually notice to say katuna keve kama cha reduce to my values to b. Alright, you can now say 231. So 2 reduces 360 all the way up to 45. 2 into 360 is 180. 180 divided by 2 is 90. 90 divided by 2 is 45. So make use of that too. So all these values are strategically placed. Okay, 11 times 7. We cannot reduce any of these values, so we cross multiply, but we're just going to list the values the way they are. We're not multiplying 231 times 45. We'll just list them like that. Then on the right we're going to have theta times 11 times 7. We're not going to multiply 11 times 7. We just divide both sides by 11 times 7, so that that 11 and that 11 can cancel, that 7 and that 7 can cancel. Remember we're doing it both sides, so even here it's going to be 11 times 7. So on the right we're just going to run with theta. At this point, remember I said 11 is a special number. Okay, let's try. This is a weird number. Can 11 go into this number? So I'm going to say 231 times 11, or divided by 11. 11 into 23, we know it can go into 22 because I said 11 goes into 2-digit numbers. Okay, 22, 33, 44, 55, 66, 77, like that. So 11 into 23 goes there twice. Remainder is 1. 11 into 11 is 1. So I know to say 11 there is 1, 11 there is 21. So I'm going to make 21 times 4, 5, and then everything over 7. Now you notice to say the 21 and the 7 can actually be divided. 7 there 1, 7 to that is 3. Then you can say 3 times 45, what do you get? 45 times the 3. 3 times 5 is 15, remainder 1. 3 times 4 is 12, plus that 1, 135. So our theta is going to be 135. Remember theta is an angle, so you remember to put the degree sign there, and you are done. I hope we are seeing how simple this question is when you follow the right steps. Okay, do you have any questions? Is it making sense? Especially those that have just joined us due to network problems. Are we getting somewhere? Okay, I'm not getting any feedback. Are we getting anywhere? Are people understanding what they are learning? Okay, all right. Okay, we proceed to our last question, which is nice, which is well, that was our last question, was it? Yes, it was actually. So that is basically that under area of a sector. So take away lessons. first things first, write your formula. Okay, master it. Don't make a mistake of saying area is equal to theta over 362 pi r. When you put a 2 there, you are taking us to earth geometry. So sector does not have a 2 there. The 2 is on the r, which is squared. Okay, once you write down your formula, you plug in the values you have been given. Once you plug in the values you have been given, proceed to the next step. Don't start reducing from that very step. Your goal for this question is to reduce as much as you can until you get to a point where you cannot reduce anymore. That is when you begin multiplying. Alright, this question is very simple, but it gets locked up. Remember, imagine just here, right here, we say 22 times 14 times 14. You don't have a calculator to give you a very big value. Okay, and then here we say 360 times 7. That also gives you a very big value, and you have a lot of problems reducing that value. So reduce, okay, reduce as much as you can, then you easily find your answer. So that is that. So we'll take a break for 10 minutes. This is 2117, and then we're going to proceed to calculus. So at exactly 21:27, we're going to start looking at calculus paper 1. So I'll be back in 10 minutes.